In this video, we want to look at resolution of vectors. Let's say we have a question, and the question says that what is the magnitude and direction of the resultant vectors shown below? Now, when we look at this vector, when we draw the vector out, so we have this vector, then we have the x-axis, positive x-axis, we have the y-axis, positive y-axis, x-axis, negative x-axis. And then the force of 20 Newton is moving or directed towards the positive x-axis at an angle 35 degrees. So we have an angle 35 degrees. Another force of 40 Newton is directed towards the negative x-axis at an angle 45 degrees. All right, now to resolve these vectors, we need to find the horizontal component and the vertical component. The horizontal component is known as the fx, and then f1x, because we'll call this our f1, we call this our f2. Now the horizontal component is fx. For this case, it is f1x. Now our vertical component is f1y for this case. Now we know that fx is equals to f cos theta, fy is equals to f sine theta. So what we're going to do is to draw a table so that we can plug in our calculation in that table so that our calculation will not be scattered. So let's draw a table. So we have the table. The force is our force. So after the force, we have the x component. After the x component, we have the y component. After the y component, we have the theta. All right. Now, what's the force? The force here, F1, is 20 Newton. All right. The force F1 is 20 Newton, and the angle is 35 degrees. Now, how do we solve for the F1? F1x. F1x now. F1x is equals to F cos theta. All right, let's do it here. So that F1x, which is equals to F cos theta, will give me 20 cos 35. All right, I can also write it here. This is 20. F1x is equals to F1 cos theta, which is 20 cos 35. All right, so for the Fy, F1y is equals to F1 sine theta. Let's do it here. So it will be 20 sine 35. You can also write it here, 20 sine 35. All right, why I have this table is that it will make my calculation neat. I can actually do the calculations anyhow on the board. When you have this table, you transfer your answer into this place. So we have the F1x component and then the F1y component. So let's go to the F2. For the F2, what we have there is 40 Newton. So we have 40 Newton. Now, for the F2 now, we have an angle which is 45 degrees. Well, for us to know, we should note that the angle is inclined starting from the positive x-axis to this direction. So it's moving from the positive x-axis to this quadrant, second quadrant. Now, this is 0 and 360. This is 90. This is 180. All right, so this is 180. The angle at the second quadrant will be simply 180 minus 45. And 180 minus 45, that should be equals to 135. So that my F2x will be equals to F2 cos theta. And that will be 40 cos 135. 40 cos 135. How do I get 135? 180 minus the 45. And I'll get my reference angle. Actually, you can put minus 45 here. You will still get the same answer. But I love using this method of solving to get an appropriate answer at the moment. All right, so we have the F1, F2 sine cos theta, so that this will become 40 cos 135, and here will become 40 sine 135. All right, please write it well. Let me write it again. This ink is too, okay. All right, 40 sine 135. Okay, now my sum of x components will be equals to my sum of y component will be equals to, now let's do the maths. Where's my calculator? All right, this is my calculator now. All right, the calculator is saying that 20, let's do it now, 20 cos 35 plus 40 cos 135. What will that give me? That will give me negative 1190. Negative 1190. So I have negative 11.90. All right. So let's do the next one. The next one is 20 sine 35 plus 40 sine 135. That will give me 39.76. So I have 39.76. Now, you can decide to be giving in your answers if you want to, but you can also decide to press your calculator and you get it once and for all. All right. Now I'm going to redraw this vector because I've gotten the new sum of the fx component and the sum of the fy component. So the new vector will look like this. Recall, observe that the x component is negative. If the x component is negative, it's going to be moving towards the negative x-axis. So my vector is going in this direction at about negative 11.90, positive to this direction, positive y-axis. Y-axis is positive, so it's moving up now. Positive y-axis, all right, at about 39.76. So what is the resultant vector? Okay, what is the magnitude? That's the resultant vector. If you are conversant with trigonometry, you will know that c squared is equals to a squared plus b squared. So that c is equals to square root of a squared plus b squared. Now, this is my x component, which I'm going to be having that c is equals to 11.90, okay, 0.90 square plus 39.76. All right, so all square. So if I do that, now you ask me, why did I put the negative value? Well, negative minus times minus is plus. When you say 2 raised to the power of 2, it's just like saying 2 times 2. When you say minus 2 raised to the power of 2, it's like saying minus 2 times minus 2. That's why I didn't bother putting the negative sign, okay? All right, now let's do the math. Now we have 11.90 raised to the power of 2. That will give me 141.61. So 141.61. This is 20. 141.61 plus. All right, let's do the next one. The next one